Hi everyone. Today we're going to talk about one of my favorite topics in computer science, and that's data and data types. If that doesn't convince you I'm a gigantic nerd, I don't know what will. But data and data types really start to unlock some of the power that we see with programming. I want to give you an example. Say I told you to just add these two numbers together. As a human, you can look at that and you say, okay, two numbers, I know how to add those two things together. Easy peasy, that's going to equal 4. But say I gave you the same instructions and said, hey, take this phrase here and just write it on a piece of paper. You'd be able to take that and go, okay, great, I can do that really easily. But if I just give the computer data like this, it will get very confused if I say, okay, but just display that to the console as is. If I tried to wrap that in a print statement and say, okay, just display 2 plus 2 to the console, what it's going to do is assume that I'm working with integers or number data types and I want it to be added together, and it's going to give me a 4. I need to be very clear and specific with the type of data I'm giving the computer in order to get the outcome that I want. And in this case, if I wanted it to just print the 2 plus 2 exactly as is, I would have to tell the computer, hey, don't treat this like a number. This is actually something we'll call a string, which you can think of as like a sentence or words or anything that you would want to see exactly as is would be a string. And if we're specifying the kinds of data that we're giving the computer, we will really unlock a lot of power in what we can do with all that different kinds of data. So in exercise 1 here, we want you to give literal values of each of the following types of data. This is very similar to different kinds of code lab exercises you'll see, where it'll say, give us a literal value for X type of data. And all you'll need to do is literally type on your keyboard what an example of that data would be. So if we're talking about, let's skip to integer here, that would be something like this, 2. That is a literal value for an integer. It's literally just the number 2. Integers, if you'll remember from the textbook, are slightly different than what we would call floats or floating point numbers because they're whole numbers with no decimal place. Floats always have a decimal place associated with them. It could be 0.0, but anytime we see that decimal or that point, we know we're dealing with a floating point number. So if we're talking integers, we could have things like 2 or 42 or negative 109. Those would all be valid valid integers here. And I'll just add a comment up at the top. So remember to do a comment. We use that hash symbol. We say integer examples. And then down here, let's do some examples of some floats. So those could be things like 3.7. They could be 8.9065. I'm not saying the same thing I'm typing, so that's highly confusing. But you catch my drift. They could be negative numbers, but as long as they have that decimal point, they would be considered to be a float. We can also do things like this. This is also considered a float. It's just missing the 0. It's a little hack so that we save ourselves some key typing. The computer just automatically infers a 0 for us. Strings are things like I just mentioned, anything that's encapsulated inside of either single quotes or double quotes. So double quotes, we could do things like Ryder, which is one of my dog names. We could also do single quotes, anything that would be encapsulated. They could have nothing in between them. That would be what we would call an empty string. We'll use that quite often in computer science, as well as this would be an empty string. You could have just a space, that's still a string as well. You can also have a number. That's a string, and it's a string because it has the quotes around it. Now when I write strings, I typically use the double quotes, just because most languages use double quotes for strings, but you can really use either or in Python, whatever you prefer. And then finally we have our Boolean values. So Boolean values are the values true and false. Now if I type them like this, are those Boolean values? And one hint might be that they didn't change color. And in Python, those are not Boolean values. To be true Boolean values in Python, they need to be capitalized. And as soon as you capitalize them, you'll see they turn purple. And that's because we have to be incredibly specific to how we specify data to computers, because computers are dumb. right? So only if we have the capitals will that work as a Boolean, and we'll be using those later on when we get into some of those control flow statements that we talked about in some of the earlier chapters. Okay. Now for exercise 2, we're asking for examples of this type of information that we see in everyday life. So what's some examples of integers we see in everyday life? Floating point data, string data, Boolean data. And what I'd like you to do is actually post this on the discussion board for course content. What are your answers to all 4 of those? And can we try to think of different ones? At least for the first little bit when everybody's posting. So try to think of examples that haven't been seen yet for all of those different ones. And I'm looking forward to interacting with y'all that way. Now for exercise 3, we have some questions that might be things that would be good multiple choice questions for exams. We have a whole bunch of different types of data or things that might be types of data, and we want to know which ones are valid Python literals. So we're going to go through this whole list, and I'll talk to you about which ones are valid and which ones are invalid, and if they're valid, what kind of data type they are. So this very first one here is just a whole number 3. That would be an integer literal, and it is valid. This one here is a floating point because it has that decimal. It doesn't need to have the 0 after it in Python for it to still be considered a floating point, so it is still valid. Similarly with C, we have another floating point of 3.00. It has that decimal, so it is valid. This one down here might be a little tricky. You'll have to remember this one from the textbook, but this is truly valid, and it's a floating point, so it's just written in scientific notation. So if you want to know what that actually looks like, what we can do is we can print that value to our console. So we'll just say print -3E1 and hit run, and then you'll see that says -30. So this is the same as writing if we were doing maybe a science class, 3 times 10 to the 1. Okay. 3E, is that valid? No, because it's missing the exponent for the scientific notation. So if we tried to run that in Python or in processing, I'll just leave the negative for the sake of argument, we get an error. The computer starts yelling at us. It tells us it does not know what we're talking about. It can't infer a default value there because it doesn't expect to infer a default value. We always have to specify that when we're doing scientific notation. This here, is it a integer or is it a string? What are your thoughts? I want the Jeopardy music playing in the background. This one here is in fact a string because it has quotes around it. So even though it's a number inside of the quotes, it's still a string. So the computer would take that and it would do string operations on it instead of integer operations on it. We'll talk more about that in some of your later computer science classes. Up here we have a phrase, the 3 Musketeers, wrapped in double quotes. So that is valid and is a string. This one here is quite interesting. It says all for one and one for all with a single quote and a double quote. And you might be wondering, oh my gosh, what is that? Is that even valid? So one way we can check is we can put it inside of our processing, inside of a print function, and just type it all out. For one and one for all. Let me just move this over slightly. And do our quotes again. And if we hit print, what do we see? Ah, look at that. We see double quotes, all for one and one for all. So what this is doing is it's using the single quote to denote a string, and then it's saying, okay, and inside of that, we want to actually print or display this double quote character. So that's one way to get around it. If you want an instance to print the single quote character, you just have to change the order of those two symbols, like so. And then you get the single quote one. So that's one of the cool tricks in Python. When we have this one here on I, we have 2 sets of double quotes. Is that valid? This one's not valid because it thinks it has an empty string at the beginning here, and then a whole bunch of characters followed by another empty string. So that's not one set of data types. If we wanted to include those quotes, you have to have the different or the mismatching types. Otherwise, it just assumes that it is a string followed by a whole bunch of stuff it doesn't know how to interpret, and then another string. So that would be invalid. It would give us an error if we tried to actually use that in Python. Similarly with J, this one is also invalid because it doesn't have any kinds of quotes around it. So the computer won't know how to interpret all of those different values. It's going to actually think that this is something called a variable name, which we'll get into in the next chapter. K, this one is valid. It might look invalid, but it's what we call an empty string. So very similar to what we have in I at the very beginning with the double quotes. We have this down here for K with the single quotes. Because remember, in Python, for a string, you can use the double or the single quotes. I feel like L I already gave away. This is invalid because it needs to be capitalized. The computer will not know that you want a Boolean. It's going to think that you have a variable named true, and it will be looking for that. And M is valid. It's a Boolean, so it's the false value for that Boolean. All right. So pretty short chapter, pretty short exercises. There's lots of good questions on CodeLab for you to practice, and I'm looking forward to all your responses in the discussion board shortly.